Hey people, what's going on? This is Rahul SriRam and welcome to this introduction to Python overview and solving two problems in Python's video. So in this video, we're going to basically solve two problems, two LeetCode problems. As you know, LeetCode is an online judge which is used for solving interview questions. There will be famous interview questions, the repeatedly asked interview questions stored in there, and we can solve them. It is like any other online judge for competitive programming. So we'll be solving only two simple and easy programs. They're not data structures and algorithms related programs, but problems. But they'll teach you a lot of Python, and we can solve them using some advanced Python concepts like Lambda functions or higher order array functions. And I'll also teach you how to use the watch mode while interpreting Python programs and how to turn Python into a type-specific declarations-oriented language. Because by default, Python is not a statically typed language; it is dynamically typed. And I'll also show you how to use the standard library, and we can import some modules in there. Like it's like importing any other classes or modules in any other language. So, and then we'll get into how to print the solutions. And not only these are the main ones that I'll be covering, but I'll also show you some right from basic to the advanced level things that we can solve the problems using Python. So why this video? Why did I was planning to make a complete Python series from a long time, but I was hesitant. Apparently I didn't want to start it just like that. I wanted to show you how efficient and Pythonic in how efficient a way and how Pythonic a way we can solve some problems, some competitive programming problems, or how can we deal with real life scenarios and coding questions using the Python skills that we are going to learn in this series. So I wanted this video to be a primer. So whatever you learn in the intro to the Python complete Python series, those concepts you'll be using in this video to solve these two problems. Like it is like the 5% of what you'll be learning in that series. So you can imagine if at all you get overwhelmed at the end of the video watching how I solve these two problems, writing from lines of code to a single line solution for these problems. If at all you get overwhelmed and if you think you need a from scratch explanation from them, then you should go on and check my complete Python series that will be uploaded in the next 2 to 3 weeks. So it will be a long series. A great couple of tutorials will be there. So yeah, let's not waste time and jump in. Okay. So the prerequisite of this video is I expect you people to have the Python interpreter already installed on your system. I'm on a Linux OS. You can pretty much use any operating system of your choice. That doesn't really matter. You should have Python working on your system. That's all. Add it to the path and fully functional. I'll be using Python 3 by the way, because Python 2, like why? That's the question. Why do you want to use Python 2 now? So yeah, so I'll open, you see this Python folder on my desktop. So I have the revert integer problem, the first one, and the even odd sums, the second problem. We'll be solving these two problems. This tutorial will be pretty quick. Let me navigate to that and see that I have those two, and I'll use VS Code as my text editor, or you can use pretty much any code editor or IDE of your choice. That doesn't really matter. It should have a great support for Python. That is the only thing that matters. So yeah, okay, let's dive into the first problem. I think this is problem number 7 on LeetCode, easy section. So yeah, revert an integer. This is pretty obvious, right? You get an integer as an input, and you have to give the reverse of that integer as output, but this should be of the data type integer only. It shouldn't be a string. But the catch here is, if at all you're giving a negative integer in there, the sign should be persistently passed to the output too. It shouldn't be a positive number, like the sign should be carried there. And also if you're having a 0 in the end or multiple zeros in the ending of the input number, then those should be discarded in the output number, obviously, because 120's opposite will be 21 and not 0 to 1, right? So we can solve these problems using any programming language of your choice. And if you are algorithm geek and solve problems, use your competitive programming skills and all, that's fine. But the way I'll be solving these problems in this video, as far as this video is concerned, they'll be in a Pythonic way. So I'll be teaching you how we can use Python to reduce the amount of code we write, and how we can use the stunningly useful tools provided by the language for us. Okay, so let us first write a function which will revert a string. Okay, then we can use that to revert a number. Okay, so I'll pass in a parameter to that function. By the way, this is how we declare a function in Python. The def keyword is used to define a function, and this is the function name, and this is the parameter that I am passing. You don't need to mention the return type or the data type of the variable that you're passing in, because this is a dynamically typed language, and the Python interpreter is quite intelligent that it itself will understand what you're going to do with the variables and all. And reassignment of a different data type variables is also possible in here. So as you can see, I'm using the underscore conventions in here. That is the pretty standard way of writing names in Python, the function names or variable names. You don't use the camel case kind of things in here. That isn't bad code, but it isn't a good practice. Okay. So yeah, how do we revert a string? I'll take a string variable, and I can use double quotes or single quotes, that anything is possible. I can also use triple quotes. Okay. So see, this is known as a doc string in Python, the triple quotes. If you assign it to a variable, it will be a string. If you are just writing it this way and not assigning to a variable, it will be a multi-line comment in Python. Okay. Yeah. So I'm not declaring the type here. By my assignment, the Python itself is taking it as a string. You can see that, right? Yeah. If at all I assign it to 5 or any number, it will be an integer. Okay. Or 5.5, and it will be a float. Cool, right? So the revert string will be empty as of then, and we'll iterate through the string that we are passing. Normally in programming languages like C or C++ and Java, these days, like in the new features of it, we are having range-based for loops and enhanced and character-wise for loops and all. But in Python, from the beginning, they are there. So I'll be taking for every character C in my string. Okay, like this is like for talking like a new programmer. For int I equals to 0, I less than the length of the string, and I plus plus, I write a classic for loop, C style for loop in there, and in the body section I'll be like accessing the characters of the string using the indexes, right? So there is no index based, like you can access characters of the string using your indices, but you can do better than that. Okay, you can directly use the C in my string. So in operator is used for identity properties. So if this is an iterable, I mean on something on which you can iterate through, like a list, for example, a Python list is something you can iterate on. So you can iterate on it, and for every entity in this string will be a character. So C will be a character in here. Okay, so what am I going to do with those every character in there? I'll be appending it to the reverse string. Actually, I'll be doing the reverse, not that, because if I do reverse string equals to reverse plus C, then you will get the same string as the output. Like, it's pretty common, right? But if at all we want to do it in the reverse way, I'll be adding every character from the in the front. Okay, like from the backward. So the reverse string will be appending in the back way. So this is the logic that will be using for reverting the string in here. And what can we do? We can return that reverse string. Okay, even if you don't have a return statement, like even if your function is returning a void thing, you don't need to mention the return data type of your function. We can do that, and I'll teach you how. So this is the general algorithm for reversing a string, right? So can we do better? Yes, of course. We are using Python and we can do better, but as of now, let us use that revert string thing in our program so that we can see that function in action. Okay, as of now, I'll use the pass variable there, and we'll use the print statement to write it to the console. Like, it's not the only way, but the pretty standard way to do that. And I'll use the revert string function and pass in my name. Okay, this is Rahul, and I'll compile it. I'll interpret it. Oops, something's wait, because I think I'll have to change my environment in here to 3.75 64-bit use open Python. Okay, cool. Now let me interpret this. I'm using Z shell, by the way. So this is my pretty terminal and all. So you get in VS Code I have this key binding for the, by the way, in VS Code if you're doing it, you'll have to use this Python extension. Where is it? The Python extension. This is by Microsoft, you see. This is very helpful. That is how we highlight the Python code that we are getting in here, and we get the tools for it. Okay, so I passed in Rahul in there and I got LUHAR as my output. Okay, that's great. Okay, then okay, so the reverse string function is working. How can I use it in my revert integer function? Okay, before caring about the sign and all those things, let us get the answer equals to the revert string of whatever we are getting, right? But if you see, we are passing, we are accessing every character in my string. So here my string should be a string. Okay, here my string should be a string. So but the number what we are getting to this function is a number, like it is of the data type integer. So if I want to convert it into a string, I'll have to use the built-in function str, which is like a constructor function, or a type conversion related function, which will take a parameter. The number is our parameter. So now this function will convert our number into its string equivalent, and that will pass it to the revert string function in here. Okay, so the output we'll be getting is also a string. So answer will be a string. You can see I did not mention the type, just on the basis of this function it assigned a type to this, but we want the answer to be an integer, right? We don't want the answer to be a string. So what I'll do, I'll wrap it in an int function. An int function is similar to this str function. Str function takes any parameter and it will convert into a string, and the int function will take any parameter. For example, here it is taking a string and it is converting it to an integer function, if at all it is able to convert it. Like if you pass characters into this function, obviously it will return an NaN. NaN means not a number. That is also a data type in Python, like integers and floats and all. Okay, so yeah, I'm not going to be very specific in these videos. I'll teach you all these from scratch, but as of now I'll be very quick in solving these problems and show you the methods that I'll be using in here. Okay, so I'll return the answer variable. So yeah, that is it, guys. I don't want to do this anymore, obviously. What I'll do, I'll pass number 120. Okay, and in here I'll use the revert integer function. Cool. And it's a common convention to have an empty line in the end of the Python file. You might not want to do that too, but that doesn't matter, but I do follow the practice. When I ensure that, see that I get 21, and you see, if I'm passing 120 as a string, I should get 0 to 1, right? But this int function, it is converting it and discarding those zeros in the pre-section of that string we are getting, and it is just truncating it to 21. That's pretty cool, right? We don't need to do that ourselves. Okay, so that is how this works. But if at all I want to add something related to sign in here, because if at all I pass minus 120 in here, I'll get an error, obviously. I think I'll get an NaN, I don't know, or an error. Yes, I get an error. See, value error. You cannot convert this 0 to 1 minus into an integer. That is the error that it is showing. It is a runtime error. Okay, we can handle these with exceptions. I'll also teach you how to handle exceptions and try catch blocks and all in the series that I'll be uploading in the next few weeks. So as of now, we won't be using exceptions for handling and all those. So yeah, how can I deal with the numbers? It's pretty simple. Like if our number is greater than or equals to 0, then we'll take a variable named sign and we'll store 1 in there, obviously, right? If at all so this is how we write if else statement in here. If, and you don't need braces for that, and the conditional over here, and all the assignments in here will be tabbed to a specific space. Okay, 4 spaces in length, and these are most important. Columns are the most important in Python. That is how we declare our scopes. Okay, we don't have the curly braces, nor do we have the semicolons in Python. So yeah, in the else case, we'll store -1 as the sign. Okay, So now I have the sign, right? Now what do? I'll take a variable called dummy because it will just store the positive version of the number that I'm passing. How am I pretty sure that only the positive version is being stored? Because if it is a negative number, I'm storing the sign as -1, and again I'm multiplying that -1 to the negative numbers, in which it will return me a positive integer. If at all it is a positive number, it is always having the sign as 1 for that, and 1 into a positive number will be the same number again. So dummy will be the positive version of the number that we are passing in, be it negative or positive. So pretty much what I'm doing here is like using the mod function in the math, or the absolute value function. Like it discards the sign and only returns the magnitude. For that I'm writing 5 lines of code. Obviously we can do better, and I'll show you how. Okay, so now I won't send the number in there, because if at all we are passing a number with signs in that, we are getting an error, as we have seen earlier. So I'll pass only the positive version of that number. So this will return the negative version without those zeros and things, the positive version of the number in the reversed way, without those prepended zeros and all. But how do I add the number to that? How do I add the sign to that, right? Pretty simple. I'm already storing the sign variable in there. So I can be like sign into my answer, and it will pretty much do that, right? If I now run it, I get -21, which is expected. And if I just pass 1 2 3 4 5 as in the example we have seen there, we get 532, right? Cool. Like for solving this problem, we wrote 5 to 20 15 lines of code. Is it cool? No, yeah, please. We Python programmers are lazy, we don't want to do things this complex. We can do it better. How? First, this function is here an overhead. We don't want to write an extra function just to revert the string. Okay, can we do better? Yes, of course. We can do better. And I think we'll have to use the list slicing and string slicing concept in here. So what do I mean by slicing? We don't need this function at all, guys. We are Python programmers, right? We don't need to do that. Instead of doing that, what I'll do is I'll take this string dummy. Let me first not confuse you and do it from the scratch. This is a string of the value dummy variable, right? And I want to revert it. And to revert it, we can access the indexes and indices of the string variable, the characters in them, using the array braces in there. We call them the squiggles. So we can access like the 0 will be the character stored in this string at the 0th position, and like that. Okay, and if I write something like 2 in there, 0 and 1 characters, like the 0th and the first character, 2 will be excluded. Those characters will be converted into a substring, and that will be stored in answer. So this is known as list slicing. We'll be slicing the main list into the characters that we want. Okay, and there will be an extra parameter called step. The step can be any variable, like if at all you're taking 2 as there, from 0 it will jump to 2, and from 2 it will jump to 4, like that. Like you can store only those even things in that list, or you can also store give negative numbers in there. So what I'll be using is the very famous trick for Python reverting a string thing, that is using list slicing. We can just do this. Okay, we pass in the default parameter for the starting index, we pass in the default parameter for the ending index, but for the step function, for the step variable, I'll be using -1, which will store the same variable, because I'm using the default, which will be the 0 and the length of the dummy string here. So over all those things, the step will be in the reverse way, not from 0 to length of the string, but from length of that string to 0. Okay, so the reversed version of the string will be stored in answer, but I want it to be an integer, so I'll make this look like an integer. Okay, yes. Oh no, not there. Okay, cool. Now, yeah, so answer will have an integer, that is the reversed version of the dummy thing that we are sending in there. Okay, now will this work? Let's check it out. Yes, it does work. -121 and obvious -121, and obviously this will work. Yeah, I'm pretty sure about it. Okay, can we do better? Of course we can do it. we are Python programmers. We don't need to do this thing, this assigning and all, storing it in a dummy variable and all. We can use the unary operators and the ternary conditionals that comes inbuilt in the Python thing. So now the solution that I'm going to show you people will be a single line solution. Okay, like literally a single line solution. Or wait, before that, let us see how we can do it using the math module. Okay, so this is the math module which will be in the standard library of Python programming language. So I can import it just like that. So all the methods and functions and variables and constants available in the math module will be in access to us right now. So how can I use it? The only thing, as I told you earlier, is I'm getting the absolute value of this in here, right? But I can get that absolute value very simply. Just I'll store the dummy as the number and nothing else. And in the number, what I'll be storing is the reversed version of that. So the reversed version of that will be the string of the number that we are storing, and as I've told you, I can use list slicing to revert it. But if at all we are passing the negative number in here, this will raise an error. So to not pass a negative number, I'll use the built-in absolute function. See that there is a function in Python built-in. You don't need to check the sign and do all that. Built-in, we get that absolute function and it will return the absolute value of that argument we are passing. So if I pass -120, it will just send 120 for that string variable, and on that string variable I'm applying the reverse string list slicing method in here. So now the number will be in integer actually. Yeah, it should be an integer. So I want to do that. I want to convert it to an integer. Okay. Yeah, now number is an integer, right? Because by default number, what we are getting there is an integer. Okay. Now, but I don't want to lose the sign. Here, while applying the absolute value, I'm losing the sign, right? That is why I've stored the actual number in here, which is the dummy variable. So what I'll do is, I don't need sign variable anymore. I'll just return the math variables predefined method or the library method copy sign. What will this copy sign method do? If you have seen my math big integer and math class video, Java's video, just the before video of this one, previous video of this one, I've dealt with math and big integer classes in Java, where we have the pretty same method and the same class involved. The math class will be having a copy sign function in there, and what will that take is it will take two parameters. The first one will be the magnitude and the second one will be the number on which the sign should be extracted from. So the magnitude should be the number, obviously, because that is the reversed thing we are getting. If you can see, I'm sending the same number in there and I'm also assigning it to the same number. And so yeah, copy sign will return a float with the magnitude of x, which is the first parameter, but of the sign of y, that is the second parameter. So what is the sign that we want to copy? That is the same as what we have initially passed, that is now stored in dummy, right? So I can send dummy in there. So what will happen? It will get the magnitude of number, which is the reversed number that we are passing, but the sign will be of the original sign that we are storing in the dummy, right? It's pretty obvious, right? And to use this copy sign method, we'll have to use the import math library in here, or the module, or whatever you call it. There is a difference between modules and libraries. I'll be dealing with that too. So this is how we import libraries and use the dot syntax to access the methods of that library, or precisely speaking, the functions of that. And there are methods like absolute and power and all, which we don't need to use any library. They are predefined, and we can just use them just like that. Okay, now let's try the solution out, and I get -21 of 0.0, which, because this copy sign will return a float, and if I want to return if I want to return an integer out of that, I can do that. I can just convert into I can wrap it around an integer function and it will convert into an integer. Okay, so that is how I do it. But this solution is not very efficient. Importing a module and using the modules in that function, the functions in the module, and it gets pretty tardy at times. The already Python language is a bit slower when compared to systems programming languages like C and C++, but you can do better by not using libraries for simple problems like this. Of course, libraries are the only way we can solve some problems, but for simple problems like this, we don't need to do all that. Now I'll be showing you a single line solution that will be not much Python oriented, but common sense oriented. I'll just return it this way. What I want to return, like I want to return the reverse of what I'm sending, right? So for that, I use the list slicing method. So this is the reverse, but I want it to be an integer, right? So I'll convert it to an integer. Why am I doing it here? Yeah, convert it integer. But when do I want to when am I sure that this will be a positive number only, right? When am I so sure that this will be a positive number only? I'm so sure that it will be a positive number if my number is greater than equals to 0, right? Yes, only if it is greater than equals to 0, I can send that. Else, if it is a negative number, what do I send? I'll send the negative of the string version of my minus num, okay? And on that, I can use my list slicing to reverse it. And why am I doing it twice? Because already this is a negative number. I'll have to pass a positive number to the string function, or else it can't convert into an integer. You get that error that we have been seeing. So I'll send it as a positive number. That is pretty much the way we are doing here, because it is already a positive number. We are sending it as it is. But in the else case, we know it is a negative number. So I'm passing the negative version, which is the positive version of that hierarchically. So what we get is the same value in here, but we want to pertain the sign that we are getting in here. So I multiply it with a negative. So this is how we use unary plus and minus operators in Python, right? So yeah, I use if else conditional and just this. I'm not using any sign variable or copy sign function or the absolute function, nothing. I'm just doing it using simple logic. And if I compile, guys, sorry, I have been I am not returning anything. See, okay, now that I can run it and I get minus 21 in there. Okay, so can I do better? Yes, of course. I keep saying this, can I do better? And I'll be like, of course, because there is obviously a better way to do it in Python. I just don't need to write 4 lines of code for this. I can wrap it in a single line. I'll take this thing over here, I'll be needing that very much. I'll use a ternary conditional operator. I think you know what a ternary operator in other languages. We use that semicolon and the colon syntax in there. If at all you know what a ternary operator and all. Instead of using the semicolon and all those things in there, we use the if else only, but an inline if else. Okay, I think you get what I'm talking about. I know I'm refactoring my code very badly, but sorry. Yes. Okay. What am I doing? I'll return this number if the number is positive or greater than equals to 0. Else I'll be returning this number. Okay. It is like return this question mark a conditional, and if it is that condition is true, only then we'll be returning this, and if it is false, we'll be doing that. Here a colon will be like this question mark and colon syntax will be used in other programming languages. In Python, we can use the inline if else statement. And yeah, so a single line solution, we wrote 2 functions initially to solve this problem, and now we are writing a single line solution there. And what I get is minus 21. So yeah, so this is how we can do it in Python. We can use modules or copy sign methods and all, or we can use the ternary operator this way, or use the absolute function. Do whatever you can. Okay, I've taught you the underscore naming and accessing characters in a for loop directly instead of using the index based like in other programming languages, and how to truncate the code from 4 lines to a single line if else statement. And I've also multiple times I've shown you how to do typecasting, and I've shown you the this method to reverse a string. There is also a reversed library function, but it will be returning an iterator, and it is quite complex to explain in a short video like this. Okay, cool. Now that we solved the first problem, let us dive into the second problem, which is quite interesting. Yeah, so return a tuple of sums of even and odd numbers in the given array. Like, we are given an array as the parameter, and I'll have to return the sums of the even numbers as the first thing, and the first variable in the tuple. By the way, this is a tuple. Okay, I can also return a string or a set or whatever. That doesn't really matter. I just wanted it to show how tuple, because in this we are only dealing with the data types, integer and string. These are plain data types that we'll be using in programming languages. But while dealing with iterables like tuples and lists and all those, we don't want to. I also wanted to show you how to do typecasting on them as well. So I just, for namesake, use this tuple as an output. I can also return a list in there. Okay, so array, or we call arrays in Python as lists. Okay, so I'll be passing this parameter in this. So 2 plus 4 plus 6 will be 12. That will be the first thing, and 1 plus 3 plus 5, which are odds in the thing, and sum of the odds will be 9. Okay, that will be the second parameter. That will be the second thing. By the way, what is this pass function that you have seen earlier? Pass is like you define something or you declare something, and you don't already want to write the body of it, or function body, or classes if you are writing object-oriented programming, and you don't want to write method definitions or class variables and all. You can write a pass statement there, which will not raise an error. Okay, it is like wait for a while, I'll come back to you, and because you don't want that red lines in your ID and all that. Like, this is a very noob way of explaining the pass statement. There are pretty good examples of how to deal with pass statements and where are they very useful. In exception handling, we can use pass statements, but for you people to understand in simple terms, I'm doing this way, okay, to overcome the errors that we will be getting if I just don't write the body of a function and just leave it like this. Obviously, it will be giving an error there. See, we don't want that to happen. So I left it by default with the definition. Okay. So before doing that, we've been interpreting this program in our, here, using this, right? Python 3, let me spell that right. Python 3 revert integer.py. Okay. I'm getting auto sessions because I'm using the Z shell. Pretty friendly shell, that is. You can use bash or command prompt in Windows or PowerShell. That doesn't really matter. Okay, so yeah, I'm doing this, right? I do that and I get -21. For this, I am having a keyboard shortcut. I'm using the ~p in my VS Code. You can just keep on doing it, but this is pain in the ass, right? You don't want to do it every time you want to check your solution. Okay, so for that, there is something called the watch mode. What does this watch mode do? Like, watch mode is not related to Python actually. It is related to the bash or the terminal that you're using. It is pretty much available on all operating systems as far as I know. At least on Mac and Linux it is there. So you see that Python 3, watch Python 3 and revert. What will this do is, it will keep on interpreting this only when there are changes in the program. Okay, like I can do that, and see, it will be like for every second, every change we do. For example, I make a change in the program by passing, if at all we are not passing a parameter which is expecting a parameter, we get an error in here automatically because it is watching the program continuously. Okay, this will be very handy if you are dealing with competitive programming and all, because you want to keep on running the program and just deal with your errors instead of running it every time you make a change, and that's quite tardy to and repetitive to do that, right? So what I'll do is I'll pass this thing and I'll just save the file, and it will get me the output of that. Okay, so this comes very handy. And to come out of this watch thing, I'll have to press Ctrl C and it'll end that program. Okay, cool. So this is how we interpret programs in watch mode. And also I also promised you to explain about the strict data type typing. Like, we don't know what this revert integer will be taking until and unless I pass in something over here, right? For example, I pass in the variable x in here. Okay, I'm passing the variable x. That is also possible for this, because typecasting a string into a string doesn't have any effect on it, right? But reverting the string will also have that is pretty much possible in there, but comparing it with a 0 and all, those will get in the runtime exceptions. If I run this program, we'll get exceptions, obviously, because we can't compare it with numbers like this, because whatever I'm spending here. So to be more specific, I can put a column there and write an integer should be the data type that should be passed as a parameter. And also to return to show the return type, I can put an simple arrow in there, like you see that arrow. Sorry guys, not there. I wanted the space to be here. Yeah, and it will return an integer 2, and I write it that way. Okay, now like it doesn't have any effect. That is why Python programmers don't do this in general. Like they want to use that strict thing of dynamically typed syntax, and that they want to use it in a special way. But if at all you are a geek and you want to be very specific on, or if at all you want the function to be very specific, even now I get the same error if I pass a string. That doesn't really matter if I mention these or not. But to be very specific, and while other people are reading your code and all, if you want to tell them, instead of writing comments or doc strings on the above, this is known as a doc string. I think I already told this, or just comments. We declare comments like this. We use that hash symbol over there, or the bang. Some people call it bang. I don't know why that sounds vulgar to me. Okay, yeah. So, and we can write something, and that will be discarded by the interpreter. Okay, now we can do this. Okay, arrow, and this will be the return data type. I don't need to do this. Like people don't do that in general. That is common practice. There is no need to do that. Okay, but I wanted to just tell you how we can do it. Yeah, now even odd sums. This is a great program, in the first program I dealt with just basic data types like integers, floats, and strings. Now I'm dealing with attributes and data structures, inbuilt data structures, tuples and lists. So how do I do this? Very simple. First, I'll store a variable called even sum. I'm writing and I'll iterate through that. Okay, for every element in the array. The array is the list that we are passing, and that is the natural numbers. Okay, so for every number in that, okay, for every integer in that array, what I want to do is I'll also have to take an odd sum there. Okay. In here, what I'll be doing is I'll be checking for it. Okay. How do we check for number is in even or odd in any programming language? We use percentage divided by 2, because that will be returning the not x. That is element, right? For every element, we want that if conditional to work, and we'll append that. I can just use even sum equals to even sum plus element, but I'll be using this short form of writing assignment and updating arithmetic operators. These are known as arithmetic assignment operators. Precisely, they are assignment operators with something doing in the process background. Okay, or if at all it is not, then I'll do this. Okay, now that we have the even sum and odd sum in there, what can we do? I can just return them as a tuple, right? Before returning as a tuple, I want to show how to return as a list. So this is how we use the list syntax, the squiggles, and I can send the even sum and odd sum there as a list, and I'll have to print them. So I'll use the even odd sums, and let me copy the same array that we used in the example and paste in here. I can send the whole array as a parameter here. That doesn't really matter. Okay, now I get a list of the sums. Okay, yeah, let me interpret it. 12 and 9, cool, right? But I want a tuple. So to get a tuple, the tuple, as you can see, they'll be in the parentheses, so I can just wrap them with parentheses. Okay, and I can do this, and now I get a tuple. I think we can also write the tuple function in there. Like now these parentheses are we'll be using the tuple function in there, which will be taking numerous number of parameters. I don't know if this will work. Let me check it out. No, it doesn't. It is expecting only one. So these are used for typecasting, and these will take only single parameters. And what they will do is they'll convert the iterable that we are sending in here, or the data structure. We can send a list in here, and that will be converted to a tuple. We can send a set or keys of the dictionary or values of the dictionary, Python dictionaries. Those are another data structures similar to lists and tuples, or sets too. So these we can send in here, and then they will be converted to a tuple. Okay, so these expect a single parameter. Okay, yeah. So we can't just do it this way. But if I want to do convert it into tuple, I'll just wrap it with these, because this is how we write tuples, and this is how we write lists. Okay, now I'm getting these, right? I'm getting 12 and 9, problem solved. But can we do better? Yes, of course. We are Pythonistas. We can do better. We can obviously do better. What is wrong here is I'm iterating through all this array and solving the problem. That is pretty tardy. If at all the array is very long array, and you are wasting your time. That is like O(n) complexity. You don't want to do that. We can, like, even the library functions, you do the same algorithm, but they're pretty handy to write, right? So we have the sum function in Python, just like the absolute function. We don't need to import any library like the copy sign method. We can directly use it like the absolute function. We have the sum function, and let's see how to get the even sums of a number. Okay, let's see how to do that. I'll just delete all this, and yeah, how do I get the even sum of the array, of the elements of the array? So what is the even sum? It will be the sum function. The sum function will be taking an iterable. It can be the very array that we are passing in there. Okay, so this will be the sum of the array, which will be 1 plus 2, 3, 3 plus 6, 10, 15 and 21. Okay, but we want only the even sum, right? We don't want the other thing to be happening in there. So what I do here, I'll have to get only the even sum of that. Okay, so before passing an array in here, I want to like the sum function iterates through all the elements in the array, and it will get that thing out of it. But I don't want to iterate through all the elements of the array. I want it only to iterate on only some iterables, only some elements of the array which are either positive or odd. That depends on in what variable you are storing this. So I'll write a helper function for this. Okay, check if even. We'll pass everything into this. We'll get the number in here, and what this will do is it will just return a boolean checking if number %2 is 0. Okay, that is just a helper function. Now we can use this helper function in our solution in there. Okay, so yeah, we can use the sum function to sum the elements of the things, but how do I filter them? Okay, so for that we are having, like, I'll have to filter between the odd and even numbers in the array, right? So the very name filter itself, there is a function called filter in there. What it does is the filter, it will take two parameters. It will take a function as a parameter. This is pretty much new. This is the basics of functional programming. Like there are some typically functional programming languages like Lisp and Scala and Haskell, and there are some programming languages like Python and JavaScript which supports functional programming or some features of functional programming. Okay, so yeah, filter is known as higher order methods. Higher order functions can take parameters as functions. Like we saw functions which take parameters as a number, and we also saw functions which take parameters as arrays or data structures like tuples and dictionaries, whatever. But there are functions, and we can ourselves write functions which take parameters as functions. Okay, it will take the function name, and there are these are not many in number, filter for each map, and there are some inbuilt functions which are the higher order array methods. So we can use them on any data structure of our want. So, and I can also mention the on which I want to apply this filter. So what is the function I want to apply? The checkif even function. We don't pass the parameters, the parameters or braces in there, because we just want to give the name of the function that we are passing, and now we'll pass the iterable that we want to do it, right? This is an array. Cool, right? So on each element of this array, it will apply this checkif function as a filter. So this is how we can understand it. Okay, the filter here is the checkif function. If it is positive, only then this will be working. The filter thing will be working. Okay, so now even sum, instead of doing it that way, so what it will do is it will filter out all the odd numbers and it will consider only the even numbers, because the true will be written only for even numbers, and all those will be appended to the evens variable in here, or they will be stored in the evens variable here. So it will be a filter type of, because it will be returning an iterator, as I've told you with a reversed method in the previous example. I don't want that to happen. So what I do is I wrap it with a list thing over here. As I told you, iterators can be wrapped like this with a list or tuple or whatever. We can't pass in multiple parameters in there, because filter is also an iterator or an iterable. So yeah, so events now will be a list. Okay, now can I print that events thing over there? Yes, I can. I can just be like print events. This sucks. So let me print that events in there, and I interpret it. I get 2, 4 and 6, and just that doesn't really matter because you are not returning anything. We get a num in there. But yeah, you see this is pretty ugly, right? We get the list in the list form, how we are passing it only in the, but we're getting the filter is being working here. We get only the events in there. But if at all I want to print those events, not like that and in another fashion, I can use this is where pretty printing and f strings come in. I think I can't deal with f strings in here, or string formatting to be precise. If at all that is pretty ugly. So if at all want to print it that way, for element in events, right, I just do it that way, and what I do is I'll print that element in there. But what this will do is it will print everything in each line, and if I want to do it in a space separated format, then I can use the separator thing in there, which we can by default is the separator by default is a/n. That is why we are getting it in different lines. But if at all I pass the separator as a string, as a space there, okay, not the separator, maybe the end, sorry guys, because this print function ends every time. If we are passing an iterator or iterable over here, we can use the separator thing there. If at all, the print function can print multiple things in there. So every time if I want to print the string, a string there, and then I can use a separator, because between those parameters that I am passing to the print function, the separator will be applied, and between all the elements in this events list, this end parameter will be used. So now when I run this, I get 2, 4, 6, obviously. Okay, cool, right? Great. Now we don't want events. We want the even sum, right? So what I do, I apply the sum function in there. As I told you, there is an inbuilt method of sum. So now I'd call this my initial name even sum. Okay, so yeah, so I can return it as a tuple even sum. And seriously, if you got the idea of doing the same thing and applying a negation operator over here and doing it like odd sum in here, you should be pretty foolish. You don't want to do that. You already have the sum function to calculate the sum of the array, and we can just subtract the even sum from that, because subtracting all the sum of the even numbers from an array will give the sum of all the odd numbers. That's pretty basic. And when I run that, I get 12 and 9. Cool, right? Okay. But can I use some other techniques in there? Yeah. There is a lot of confusion between the 0 and is operator. Is operators are, we can use them analogous to or double equals to sign and all of them. That doesn't really matter how we are doing it. Okay, there is a difference between double equal to operator, like, or the equal to equation operator, and the is operator. It will also check the data type, but the double equal to operator will only check the values of what is happening in there. It is like double equal to and the triple equals in JavaScript. There is a difference between, like, the double equals in here is the double equals in there, but the is operator in here is like the triple equals in JavaScript. Okay, like, they are similar, but there are other functionalities too. So is will also check if this is 0. And can I do it better? Obviously I can do it better. If at all I want to change this function to is odd, then I can use is not. And not is an operator in Python. Okay, not is not a keyword. Not is an operator. It is like the not operator in other programming languages. Here we don't have the not and double ampersand for and double those straight lines. I don't know what you call them, beams maybe. I call them a beam, or cursor lines basically. As or, but in here we have the a and d for, name, the plain name a and d for and operator, not not for the not operator, and or for the or operator. Okay, so if at all we are checking is odd, check if odd in here, then I can do that too, right? And I'll get the odd thing there. And I want to pass the sum of error minus odd sum, and here I just want to return the odd sum. So this is how it works, right? Yeah, 12 and 9. Cool. But we don't need to define a function in here, name it something, and pass that name to the filter function as a first class function. By the way, this is known as the higher order function, which will take a function as a parameter, and this is known as the first class function, which will be passed as a parameter. Okay, so in programming languages like Python and JavaScript, we can make functions which will take functions as parameters, and we can also write functions which can be passed as parameters to other functions. Okay, that is the basics of functional programming. We have currying and lenses, lambdas, and unnamed variables, immutability, lot of concepts. I'm pretty good. I am not boasting, but I like functional programming very much, and I'm a very big fan of functional programming in the practices. It deals with immutability and memoization. So yeah, so a little bit of functional programming. How can I write lambda functions? Like instead of naming this function and passing it as a named function here, I can just do the same thing using Python-Lambdas. Python-Lambdas are pretty new to the so I can use the lambda keyword, and I'll get the same parameter number there. Like lambda is a function. It'll take, it's like a keyword that like after that it'll take a parameter in here. I can take multiple parameters too. As of now we need only a single parameter, and I don't need a return statement. Whatever is returned I can write it in here. Okay, so what can I write here? It will be not of x and logical 1. By the way, x not x, come on, number and logical 1. That is the other way of doing number percentage 2 equals to 0, or I don't need a not here because I'm checking the odd here. Okay, if at all it was even, I should use the opposite of it. So not, because number bitwise end, this is a bitwise end. I think that doesn't look a bitwise end because of my font. Sorry guys, excuse me. I'll change my font to some other thing there, and I'm pretty sure this is another font that I use. Cool, right? I think now you can see, yeah, see that is bitwise end, right? So number and 1 will check and return if it is an odd number, but if it is an odd number. Okay, so instead of writing, like, I can pretty much do that even here. Okay, and 1, it returns a boolean. Okay, this returns a boolean. Check if add returns a boolean. This returns true if number is odd. You can check it by yourself. Okay, you can apply that logical AND with 1 on the odd number and get true, or you get one variable in the last significant bit if it is typecasted. We are returning it. Yeah, see, so what I'm doing here, I'm just writing. Do I have a function for this, a name for this function? No, this is known as an anonymous function. So lambdas are used not to write functions like this, but we use a pretty def, write a function that way. But lambdas are pretty much used for writing first class functions like this, which in higher order methods, and also we can use lambdas in for unnamed functions or anonymous function. We don't need to name the function for just a simple purpose. We just want to check if it is odd or even. Okay, so what it takes, lambda, a parameter, and a colon there, what it should return. Okay, no return keyword, no arrow mark, nothing. This is analogous or similar to the arrow functions in JavaScript. Arrow functions are also same. They just take the parameter or the group of parameters in braces, and an arrow will be there instead of the colon, and there will be no return word or return keyword before what we are returning. We just type something and that will be returned. Okay, cool. Sure. So that is why these functions out to return something. Okay, they are used for functions which are of the returning data type. For void functions, for printing something to the console, and we don't use lambda functions for such functions. We write pretty normal functions for that. Okay, so yeah, I'm using lambdas in here instead of writing all that, an in place anonymous thing. And yeah, so what can I do now? I can compile it, or I interpret it and I get the same thing instead of writing another function. Okay, but can we do better? I can't say we can do better, but there is another way of doing it. Okay, so what is the other way of doing it? It is none other than the list comprehensions, which are very beautiful, and you get pretty excited solving problems using slicing and comprehensions. I'll be using list comprehensions in here. There are dictionary comprehensions, tuple comprehensions, and also set comprehensions, but these are very interesting. Okay, so first let me get back to my events array. I want it to be a list, right? So this is how I'll initialize to an empty list. See, I just open and close my braces in there, squiggles in there, I get as a list data type. And what can I take in there? I can just take it like ARR, and this is the wrong way of doing it. We can't just type. If at all I want to copy this, if at all I want to ARR to be stored, the same ARR to be stored in the events array, then I shouldn't do it this way. People think that we are typecasting it to a list by wrapping in this. That isn't possible. What it will return is a list containing a list as something. You see, a list events which will be containing a list known as ARR. So that is what we want. That is not we want. We want the ARR list, the events list to be the same as this thing, right? If I do it this way, it will take events as a tuple and it will return that. Okay, but I don't want that to happen, right? So what I do that, I take a list there, and now you can see that even events is the same as the ARR, and there is nothing like an ARR as a member of that events list. Okay, everything is copied, but this is shallow copying. If at all I change the ARR elements, then even events are changed. Like the references are being passed here. Okay, like I stored a duplicate in here, but if I change the numbers of the members, the elements that are existing in ARR, even those will be changed in the events array. And if I don't want that to happen, there are some pretty good way that comes under the concepts of references and deep copying and shallow copying in Python. I'll be discussing them in the series too. Okay, so now cool. I just don't want everything to be this way, right? So what I'll do is I want a list, and listen to this carefully. I'm explaining list comprehensions in here. I want an element to go into this events array, and that element is an element that is present in the ARR that we are passing. Okay, in the ARR we are passing. So for element in ARR, this is like pretty much writing that the first way how I did it. I wrote a for loop. I accessed each and every element in that array, and I wrote an if conditional in that for loop. If at all it is satisfying, I'm pushing it to an evens array. If it is not satisfying, I'm pushing it to an odds array, and the last I'm returning the sums of those arrays, right, using the sum function. But here what I'll be doing is, I'll be doing all those within these braces, okay, a single line solution. For element in ARR, we want that to be sent into this evens array only if not of element and bitwise one. See, like this will check if it is an odd number, and that will return it true if it is an odd number. We want to negate it, so I'll use the not operator. So this conditional will be true only if this element in this array is a positive number, and if this condition is true, this element will be pushed into this evens list. Okay, for element in element in ARR, if not of this thing. Okay, so understand the syntax very carefully. For each element we are checking this condition, and if this is true, we are checking this element, we are pushing this element into here. Okay, so now evens will be an array, or precisely a list of 246. We want the sum of it, right? So I can just wrap it, because a sum takes an iterable as my so I can be like even sum, right? Cool. Now how do I return that? The pretty same way how we did that, and even sum, and the sum of the array minus even sum. Okay, now if I do that, I get 12 and 9. Cool, right? Instead of looping over everything, or writing lambda functions, or you see, lambda functions are a pretty nice way to do it, using higher order functions like filter, map, and all those. It's a pretty way. This is not a simpler way of doing it. This is just another method. Unlike what I told here, this is the simpler way of doing what we did in the previous slides. Okay, so yeah, that is it, guys. We're using I taught you how to use, like I mentioned a lot in here, right? In here I told lambda functions, I dealt with it. Higher order functions, type specific declarations, I told you how to name the type specific things. Watch mode I taught you, and pretty printing, that separator and things over there. And I also told you how to use the math library or use the standard library functions. But I also explained about many other functions like typecasting with list strings and all. The bitwise tricks that I've shown you for checking if it is an even function or an odd function. I've shown you how to reverse using list slicing, that colon -1 thing, or the reversed array method. I've dealt with many things. So you saw me how I solve these problems very simply using the tools provided by the language itself. There is not much algorithms that I've used in here to solve the problems, right? There are pretty good equal and equally efficient data structures as they are in other languages. Like we have the STL for C++, and we have collections framework in Java, and here we are having IT tools and many other modules. So yeah, so this is just the 5% or the 10% of what you can do if you take this series and complete Python series and watch these videos carefully and practice in parallel. So I just wanted this video to be a primer, and wanted to show you how good Pythonic programmers you can get if you follow the series that we'll be dealing. So let me get into the second part of the video, which will be introduction to my complete Python series. Woo! Pretty long, right? Yeah, this will be a very good series. Like, this is my first series that I'm doing on YouTube. Till now I did plain single tutorial videos. The markdown tutorial, it's a single video, nothing will be linked to it. Yeah, so maybe tomorrow or the day after, I think I'll be releasing a Python beginner's crash course video, which will be pretty lengthy. It will be dealing with all the things, very, very basic things, writing functions, what are try and except blocks, writing classes, and assigning and just copying something. What are the basic data structures available? What is an iterable? Everything. How the scope is being handled in there. How to write if statements. What are ternary conditions? And all of them. I'll be dealing with all of them in the beginner's crash course. But this is not the actual Python that we'll be dealing. I'll be having something extra. So what are those videos? Advanced input and output will be a little competitive programming related, because they'll be giving us space separated integers as input in competitive programming, and many people don't know how to take them and store them in a list or do manipulations on them. Okay, or they'll be giving files as input in some competitions, contests like Google Hashcode and all. We don't know how to take the input from a file and convert our output into a file and all that. So for that, the advanced input and output techniques in Python, I'll be dealing with many things. I'll use list comprehensions. I'll be using higher order array methods, map, and all those to take the input and output. I'll also show you how to use the input prompt in there, how to typecast the input right the way we are taking in there. So that will be a pretty advanced video related to input and output. Then we'll go through numbers and the inbuilt functions. I've shown you the sum and absolute functions. There are many other functions like very handy functions. Like we have a function called factorial, which gives a factorial of the number. They are that good functions in Python. I'll be dealing the most important ones, and I'll also show you how to use the math module. I think I only taught you how to use the math module in a pretty basic way in this video. I'll also show you the constants available in there and what is the difference between the inbuilt functions and the math module functions. There are some repetitive functions in there and all those. Okay, so that will be the third video in the series. Next, we'll get into strings and string methods. There are many inbuilt string methods to split your strings, to return a substring out of it. Like there are many methods in Java too, but Python has got something very special. And I've shown you. I'll also deal with string slicing in here. The trick I've used in this video to revert my string. And I think there are other output formatting, like the format method, the strings and doc strings. They'll be dealt in input output and also in this here. And the doc strings I told you that those three strings, and they act as if they are comments, multi-line comments, but at times we can also use them as multi-line string variables. So I'll be dealing in an in-depth way in this fourth video. And then comes the most important video in Python. I told you how we use the semicolon, and everything tabbed or indented in the same way will come under a block. So that will be a block scope. I only dealt with block scope in here. I did not see local scope. I only dealt with local scope in here. There are other scopes too, global scope, and LEGP are 4 scopes, and there is a rule for that, and scope resolutions. How it can be very difficult to solve problems when they are scope related, and how we can efficiently handle them. All those will be discussed in this video. Then comes this is a pretty tricky video. Iterables, generators and iterators, the yield syntax, and what are generators? How can we deal with functions which return iterators or which returns iterables and not the inbuilt data structures like lists and strings? How can I deal with them, and how can we typecast those iterables and all? Okay, so I'll be dealing with the inbuilt data structures or the 4 iterables we are having in the Python Python standard library, the lists. And I'll also again revisit the string slicing and list slicing here. The same concepts of string slicing can be applied on lists too. I'll also deal with the range functions in this series. I have not mentioned in here, but range function is also an iterable. Okay. Then tuples and name tuples. Name tuples are pretty new to Python, and similarly sets and frozen sets. Frozen sets are also pretty new to Python. These are some advanced data structures. And then comes the dictionaries video. This is pretty interesting. Dictionaries video will we have some complex concepts like zipping and unzipping. We can pretty much anything with that. Take the only keys and pass it on to convert it into a list of something and do stuff with that. And we have packing and unpacking, which we can pass the dictionaries and the values of the dictionaries into functions. We can unpack them and pack them. Okay, and I also have the enumerate function. Enumerate function is a pretty good function, and it uses a splat operator and all. I'll be dealing with all those in the dictionaries video. I also have the range function in here. Okay, so then comes the introduction video to my functional programming series. There will be a series parallelly running to this Python series too, which is known as the functional programming in Python and JavaScript. Mind it, and JavaScript, not only Python. It's not or, it's and. I'll be solving problems and explaining complex like in functional programming, like lenses and currying and partial application functions and immutability and mutations and there are many stuff to visit and explore in functional programming. I won't be dealing in a functional programming language. I'll be using the Python and JavaScript languages parallelly, so that it's not about the syntax, but it is about the concepts that you'll have to take that out of that series. So this video will be like an introduction video to all that. The first class functions, the lambdas, higher order functions, what are decorators, and what are all those will be in a there are some pretty good FP related modules in Python too, like the math related module will be for numbers, okay, and this is for functional programming module. And I'll also deal with multiple arguments, and I'll revisit packing and unpacking in this, okay. Multiple arguments, arg star, and that splat operator, quarks in there, the command line arguments in Python programming, and all those I'll be revisiting here because those are related to Python, okay. Yeah, and then there are many anti-patterns. By anti-pattern, it is like a design pattern. I think you know what a design pattern is. It is something related to OOPS, an advanced version of OOPS. It's like a practice, a practice of doing your programming. So there are some anti-patterns, by anti-patterns I mean there are something which shouldn't be used in Python, but they give us a solution, and those will be used. For example, the getters and setters and constructors, and private access methods and private methods, and accessing public variables in private methods, and all these, accessing private variables in public methods in complete object-oriented programming languages like Java and C++ and all. Like C++ is not complete, but yeah, but in languages like those. But using those solutions in Python is not a Pythonic object-oriented way of doing it. So those will be anti-patterns. Those come under anti-patterns. So how to deal with them? Okay, how to deal with them, and how to write Pythonic way of OOPS. Okay, so I'll be dealing from scratch how to write classes, how to write the constructor functions, how to write the decorators. These are the functional programming decorators, and they can be extended to classes too. I'll be dealing here. There'll be static methods, and I'll be dealing all of them in the OOPS series, okay. And then comes the files, here input and output with files, writing into a file, reading a file, appending something to a file, all the basic operations that we can perform on files, and exception handling, the try-catch blocks, the raise and raises keywords, writing our own exceptions, okay. And how can I deal with context managers while coming into files? Context managers come in very handy when we deal with files, okay. Yeah, so then there'll be a special video on comprehensions, because I love comprehension. You saw how I use comprehensions in the second problem, even odd sums. Okay, I only dealt with lists in here. We can do that on sets and tuples and whatever data structures, and we can also do some pretty complex stuff in comprehensions. Okay, and I'll also show an analogy of comprehensions to SQL. SQL is the SQL, insert all, or select star from, and all that syntax is pretty similar to comprehensions. I'll show the analogy in a detailed way so that you cannot forget and get confused while dealing with list comprehensions and all that. And in the final thing, I'll be dealing with modules and packages. What is the difference between a module and a package? How to write a package, and underscore init methods and all that. By the way, in the functional programming video, I'll also dealing with the dunder methods or the magic methods. There are like double underscore methods. We also call them the dunder or magic methods. Those are pretty useful in OOPS too. I'll be relating them. And then comes some modules in standard library like OS, to relate to the operating system. We can use the OS module or regex module. Regex series will be a completely different series. In the first video of that series, I'll be dealing the basic regex, the regular expressions. Second video will be Python related. Third video will be JavaScript related. Simple. Okay. Similarly, there will be a JSON series too. JSON, the first video, these are 3 video series. The first one is in JSON video will be the basics of JSON, JavaScript object notation, by what I mean JSON is. Then comes the Python and Pythonic way of handling JSON and using JSON and all in the using JSON as a module in Python. And then comes the JavaScript way of dealing with JSON, and there I'll be introducing you to the asynchronous programming in JavaScript series too. So all my series will be linked this way. I'm planning it, so I took a gap for planning all these and making course structures out of these and too. So, and remember, the list goes on. This is not what complete Python, but you should be a pretty good Pythonic programmer when you complete this series, all these 12 videos and all. So these numbers, input, output, scopes, iterables, list tuples, functions, writing classes, all these I'll be dealing in the beginner's crash course too, but not in detail. These crash course is very important. You cannot skip this, because whatever I dealt in here will come in handy while dealing with all these videos, because these are some intermediate and advanced stuff that we'll be talking in here. You cannot watch this functional programming video without knowing how to write a function and how to return something in there, okay? Nor can you deal with comprehensions without watching the beginner's crash course or the list and strings thing, okay? So all these are connected, and there'll be an add-on to setting up a Python development environment is an add-on. I don't know when that video will be returned. I'll be releasing that video, so I mentioned it there. I'll show you how we can set like that will be a mini series of its own, because we have some package managers in Python like pip on PyPen or Conda package manager, or we have virtual environments, okay? What is a virtual environment? Basically downloading the Python interpreter and adding it to the path. All those, all the package managers, what are environments, how can I deal with environments, how can I create a virtual environment, starting the virtual environment servers, starting a Jupyter notebooks. I'll be dealing with Jupyter notebooks too in that series. And if you are into data science, I'll be teaching you Jupyter notebooks and Anaconda, how can I use Anaconda and Conda prompts and all those will be coming in here. Those will be random. I don't know, between this series, some or the other, between 2 or 3 videos I'll be releasing these. They'll be short videos, but dealing all the most important thing I'll be using in here is PyPen. PyPen is what I use personally. You can use pretty much anything. You can use pip and whatever be it. So yeah, so this is it with this video, guys. So I hope you'd like the Python series that will be releasing from the day after or within the span of 2 days. The beginner's crash course will be available to you. So I hope you liked the way I solved these 2 problems, and if you want to solve and gain the same knowledge as I do, or you see, even I'm a learner, even I'm learning Python day to day, and I'm interested in teaching and I'm teaching. So if you want to learn with me and solve problems efficiently using the Python language, because you don't need to learn Python because of peer pressure. It is not that kind of language. You want to learn it, right? Because it has got some pretty cool features in it, and I hope you're looking forward for that series. So signing off, we'll be back with an awesome series.